Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 4th, 2025, about 7 days ago. The big contribution is a clear, end-to-end survey that defines what world models mean in 3D and 4D, and organizes the field into a practical taxonomy with datasets and metrics that practitioners can actually use. The paper is titled 3D and 4D World Modeling, a Survey, and as we will see later, the implications for evaluation and deployment are quite significant. In short, the survey separates video-based, occupancy-based, and LiDAR-based approaches, outlines roles like data engines and neural simulators, and highlights challenges like physical fidelity, controllability, and real-time efficiency. Also, the authors shared a GitHub repository. Listeners will find a polished project page, an updated README, and the full survey content organized into sections on benchmarks, datasets, and 3 paradigms: video, occupancy, and LiDAR. It includes tables of models, links to papers, applications, and citation details under an Apache 2.0 license. So the figure distills the survey's scope and roadmap, showing what counts as world modeling and how the review is organized. The left icons mark 3 modalities, which are video-based, occupancy-based, and LiDAR-based streams. The definition column splits roles into data engine, action interpreter, neural simulator, and scene reconstructor, which clarifies what a system actually does. The methodology and data columns list conditioning types and evaluation tracks, so applications and future trends connect to concrete metrics. So Figure 2 maps the field into 3 streams that align models by modality and role, which helps readers see coverage and gaps at a glance. The branches label video generation, occupancy generation, and LiDAR generation, and each branch groups methods as data engines, action forecasters, neural or autoregressive simulators. A small bar chart counts yearly papers, which signals rapid growth. This layout matters because taxonomy plus timelines guide dataset choices and evaluation plans across applications. Table 1 spells out the control signals that make 3D and 4D world models practical so designers can match inputs to tasks. The table groups conditions into geometry, action, and semantics, which clarifies how viewpoint, motion, and intent steer generation and forecasting. Geometry covers items like camera pose and past occupancy, which enforce spatial consistency. Action includes ego trajectory and route plan, which guide predictive rollouts. Semantics lists text prompt and scene graph, which add high-level intent for controllability. So Table 5 organizes the go-to datasets for training and evaluating 3D and 4D world models, which helps match tasks to the right data and conditions. The table lists dataset name, venue, scale, annotation frequency, available conditions, and which model types they support. One unusual column is conditions, which encodes control signals like geometry, action, and semantics so models can be steered during generation or forecasting. Practical takeaways include which sets offer occupancy or LiDAR scenes and which are suited to video generation or planning-aware tasks. Alright, 2 takeaways stand out. First, a clean taxonomy that separates modality and function gives shared language and metrics, so researchers can compare like with like. Second, native 3D and 4D models unlock physical fidelity and controllability needed for robotics, driving, and digital twins. Thanks for listening. I am Alex, signing off from AI Research Roundup.